All right, today we're going to be looking at solving rational equations. So taking these rational expressions that we've been dealing with in terms of multiplication, addition, and subtraction, and division, and all those things, and we're going to kind of tie it together in order to solve these things. And really, we're going to approach this the same way we've always approached fractions, just like when we're simplifying rational expressions. We treat them just like we would fractions, except they're a little bit more complicated. We're going to do the same thing here. So if I can consider this first example, if I were to look at something like this, and I wanted to simplify this, to solve this, there's a couple ways we could go about doing this. Most of you would probably do this. You'd probably distribute the 1/2, and here you'd probably distribute the 1/3, and it almost makes this thing look a little bit messier. You get the 1/2 x plus a 5/2 minus 4 equals. Over here I get a 2/3 x minus 1/3. When we look at this, this is a disgusting mess. And if I were to try to solve this, keeping the fractions in here, I'd have to start getting common denominators and all that stuff. So remember, the trick that we have whenever we have a function that has, or an equation that has fractions in it, is we want to multiply through by the common denominator, okay? And this has come up a couple times, but if I want to get rid of all the fractions, I multiply through by the common denominator. So as I look at all these fractions, I've got a 2 and I've got a 3. So the common denominator here would be a 6. So here's what I'm going to do. I'm just going to multiply each side by 6. I'm going to multiply through by the common denominator. And essentially what I'm going to do is I'm going to multiply out these fractions. Okay, so I multiply each side by 6. Whenever I do one side, I have to do the other side. Over here, I'm going to distribute that to all three terms. And when I do that, over here it gives me a 3x plus, that's going to be a 15 minus a 24. Over here, when I distribute that 6, let's see what that looks like. So I'm going to distribute that 6. That's going to give me a 4x and a minus 2. And now from here, I have a relatively simple equation to solve. I'm going to go ahead and combine like terms over here. And let me rewrite that up top. So that's going to give me a 3x. When I combine the 15 and the minus 24, that gives me a negative 9. Equals 4x minus 2, and then I would just try to get the x values on the same side, so I'm going to subtract the 3x from each side. But we have a relatively easy equation to solve. Now I'm just working backwards through order of operations, and now I add the 2 to each side. And we can see how much easier this was as soon as we got rid of those fractions. So it looks like I get a negative 7. But as soon as I get rid of those fractions, the problem becomes much easier. And again, just a reminder, the way I get rid of those fractions is I multiply through by the common denominator, all right? And we're going to take that same thing and we're going to apply it to some more complicated examples, to some rational equations. For example, when I look at something like this guy, this thing looks super complicated the way it's written because I've got all these messy, disgusting fractions here. And so I'm going to approach it the same way. I want to get rid of these fractions. In order to get rid of these fractions, I just have to multiply through by the common denominator. So as I look at these denominators, think about the process we went through for getting common denominators before. We would just make sure all the denominators had the same factors. And so when we look at this denominator wants a factor of x minus 1 because the other ones have that. So if I got common denominators, it would look like this for this one. And this one would want the x minus 2. So if I got common denominators, it would end up getting the x minus 2 and then have an x minus 1. This one already has the common denominator. So when I look at this, if I were to get common denominators, I'm not actually going to get them. But if I were to get common denominators, this is what the common denominator would look like. It would be the x minus 2 and the x minus 1. So here's what I'm going to do. I'm just going to multiply everything by that common denominator, okay? So I'm going to take that thing and multiply by the common denominator. Whatever I do to one side, I have to do the other side. So over here, I'm going to multiply by the common denominator, which is x minus 2 times x minus 1. All right. Over here on this other side, I'm going to do the same thing. I'm going to multiply by the common denominator. And the common denominator is basically just a list of all the factors that I would need for each denominator, which is the x minus 2 and the x minus 1. All right. And now I'm just going to use my distributive property a little bit. Now it's multiplication. Over here, I just have one thing that I multiply by. And when I do that, if I treat this almost like over 1, what I do, remember, when I'm multiplying two fractions, I just cancel out anything in the numerator with anything in the denominator. The x minus 2's cancel out. So I just have the x minus 1 times the 3, which I distribute. It gives me a 3x minus 3. All right. Over on the other side, I've got to do this twice because I have to distribute to each of these fractions. So here's what that looks like. I've got that first fraction 1 over the x minus 1 times the x minus 1 x minus 2. And again, I can just say that that's like over 1 to kind of simplify that a little bit. I also have to do the same thing with the next fraction. So I've got this plus sign. I have this next fraction, the x minus 7 over x minus 1 minus x minus 2. But I'm going to be multiplying that by this thing because, again, I'm distributing. I'm multiplying each fraction by this thing. And I can think of that over 1. So now just think about things canceling out. Over here, the x minus 1's cancel. So that's just going to leave me with an x minus 2. So this side doesn't change. I want to stick with my blue. So I get a 3x minus 3. Over here, again, those x minus 1's cancel, so I'm left with x minus 2. Over here, the x minus 1's cancel, and the x minus 2's cancel. So the only thing I'm left with here is a 7, so I get a plus 7. And now look at how simplified this has become. All right, again, by multiplying through by that common denominator, it looks a little bit complicated as we approach it. But then we're just applying the same rules we applied when we were multiplying rational expressions. We cancel anything with in a numerator with anything in the denominator, and then we just simplify. All right, and what happens here is all the denominators end up canceling out because I'm multiplying through the common denominator. Now I can finish solving this thing. All right, so I'm going to combine some like terms. So I've got some like terms here that I can combine. When I do that, I end up with a 3x minus 3 equals an x plus 5. And now, of course, I want to get the fractions all on the same side, or the variables all on the same side. So I'm going to subtract that x. That's going to give me, if I bring it up here, that's going to give me a 2x minus 3 equals a 5. And now, of course, I finish solving this thing. I add the 3 to each side. I end up with a 2x equals 8. I divide each side by the 2, and I find out, if I bring it up one more time, that x equals 4. And the only other thing I need to do is I need to plug this back in and make sure it works. And really, by plug it back in and make sure it works, I just have to make sure that it's not an extraneous solution. I have to make sure that x is not one of my domain restrictions, really. When I plug it back in, I'm just trying to make sure that I don't get 0 in the denominator. And so when you look at the original problem, when you look at these denominators, you can see right away the two domain restrictions would be that x cannot equal a positive 2 or a positive 1. And since this is not any of my domain restrictions, the x equals 4, it means that that's a valid solution, okay? So again, just think about it in terms of domain restrictions. That's why we look at domain restrictions, so we can start to apply that to things like this. So basically, we're taking everything we know. We're taking a little bit of addition and subtraction in terms of getting common denominators. We're taking multiplication and how we simplify using multiplication, and then our knowledge of domain restrictions in order to kind of bring all these things together, all right? And it looks really complicated, but it becomes much simpler as you work through a couple examples. If we take a look at another one, if I look at this guy, again, we look at the denominators. Well, there is only one denominator. If I were to get common denominators, it's that x minus 1, so I multiply through by the common denominator. It's right here. I multiply this side by x minus 1. Whatever I do to one side, I have to do the other side, so I'm going to multiply this side by x minus 1, all right? Over here, I have to distribute to each of these. And a nice way to think of this here might be an easier way to think of it. I just write it all as one fraction as a 3x and then the x minus 1. Kind of leave it in factored form over the x minus 1. Plus, here I have 2 times the x minus 1. Over here I have 3 times the x minus 1. It's all still over the x minus 1. And now go from here and start simplifying. Here the x minus 1's cancel. Here they cancel. Here I'm going to distribute that too. All right. And what happens here is I get all this stuff that cancels out. I end up with 3x plus 2x minus 2 equals 3. And so now I've greatly simplified this thing because I've gotten rid of the fractions by multiplying through by this common denominator. Now it's just a matter of combining like terms, and I'm going to finish solving. So here I combine those like terms. That gives me a 5x. So I have 5x minus 2 equals 3. And now to finish solving this thing, I'm going to add that 2 to each side. When I do that, this is going to give me a 5x equals 5. And now from here I divide each side by 5. And so I end up with x equals 1. And I just have to check that against the original problem. Think about what the domain restrictions would be for this original problem. Think about trying to plug this thing back in. And so if I bring this off to the side, if I think about the domain restrictions, if I set that denominator equal to 0, you see the domain restriction I get is that x cannot equal 1. And so the one solution I got is invalid because it's one of my domain restrictions, so there is no solution for this one. So I say no solution, all right? And that's why it's really important to account for those domain restrictions. I want to know if my solution is valid, all right? If I take a look at another one, if I take a look at something like this guy, again, I need to identify common denominators. So think about what these denominators would be. You have to factor this thing completely just like I've done in the past. So this is a 4 over x plus 1. That's already factored. This is a 1 over x minus 1. That's already factored. The only one I can really factor here is the x squared minus 1, which that's a difference of squares. So that factors into an x plus 1 and an x minus 1. And so now when you think about the common denominator, if I gave all of these denominators all the same stuff, the things that they would have would be the x plus 1 and the x minus 1. So the common denominator is x plus 1 along with x minus 1. All right? It's all the factors of each. And so I'm just going to multiply each side by that common denominator. Oh boy, I made a mess over here. Let me see if I can get rid of that. There we go. So the x plus 1 and the x minus 1. Dragging my hand all over the place, making a mess. So my common denominator is the x plus 1 and the x minus 1. Whatever I do to one side, I have to do to the other side. I'm going to multiply that by x plus 1, x minus 1 as well. And then, again, just think of it in terms of a fraction. If I were to distribute this first fraction over here, so I'm going to distribute this guy to each of these. Over here, I'm going to multiply it by just this one fraction. So here's what I end up with. I end up with 4x plus 1, x minus 1. Over x plus 1 minus, over here I end up with 1 times x plus 1, x minus 1. And I'm just writing all these out because this just generally tends to feel a little simpler for students when they just write out each of these fractions. And then the last fraction over here is going to end up, oh, that is ugly. That is an ugly looking equal sign. Let me try that again. Is going to be a 3 times the x plus 1, x minus 1 all over the x plus 1, x minus 1. All right, so now what I do is I just start canceling numerators and denominators. Over here the x plus 1s cancel. Here the x minus 1s cancel. Here the x plus 1s and the x minus 1s cancel. So look at the equation that I'm left with here. Here I do the 4 times the x minus 1, which gives me 4x minus 4. Here I'm going to just be left with a minus x minus 1, but I'm going to distribute that negative sign. Again, think of it this way. This is like adding a negative 1. So think of it as distributing a negative 1 here. That's going to give me a negative x minus 1. And it's all equal to, over here, I'm just left with a 3. So then after combining like terms, let's bring this guy way up here. After combining like terms over here, I end up with a 3x and a minus 5 equals 3, and now I just finished solving this thing. I add that 5 to each side so we can see how simple the equation that's left is. Again, I want to multiply through by that common denominator, and now I divide by the 3. And the last thing I do is I just check this up against the domain restrictions. Think about what the domain restrictions would be here. If you think about that common denominator, if I think about this common denominator of x plus 1, x minus 1, that would tell me that x cannot equal a positive 1 or a negative 1. So those would be my two domain restrictions, which x equals 8/3 doesn't fall into any of those. So x equals 8/3 is a valid solution. Okay, so I can stick with that answer. All right. This next one's kind of an interesting example because, again, I could approach it the same way I did the last couple and go ahead and identify the common denominator here. And the common denominator for this one would be an x plus 4 and a 2x minus 1. And I can multiply each side by that. But since I have two fractions set equal to each other, since there's a single fraction over here and a single fraction over here, the go-to method here when I have two fractions equal to one another is to cross multiply. And this is one of those things that we kind of abuse and we try to apply it to situations where it doesn't work. This is the one situation where we can cross multiply, where I take a numerator times denominator and the other numerator times the other denominator. All right, it's when I have two fractions set equal to each other and just a single fraction on each side, and that's what I have here. So here I'm going to cross multiply. I'm going to take the 2 times the 2x minus 1, and I'm going to take the 5 times the x plus 4. And what that looks like when I do like the 5 times the x plus 4, it's going to be my distributive property, 5 times x plus 4. It's going to look like this. And the same thing on the other side, when I take the 2 times the 2x minus 1, I'm going to write it as a 2 times 2x minus 1. And then from here, I'm just going to distribute, and then I'm going to finish solving what's left here. So I use my distributive property on each side. That gives me a 5x plus 20 equals, again, a 4x minus 2. And now to finish solving this thing, I got to get my x on the same side. I'm going to subtract the 4x from each side. That's going to leave me with an x plus 20 equals a negative 2. And then, of course, I'm going to subtract the 20 from each side. And when I do that, I forgot to write it on the other side. We don't want to leave any work not shown here. There we go. So I find out that x equals a negative 22, but just like in my last couple examples, I still have to kind of think about my domain restrictions here. And for this one, I get two separate domain restrictions. That first denominator gives me a domain restriction. It would tell me that x cannot equal a negative 4. That is a really ugly looking negative 4. Let me try that one more time. The second denominator, if I were to set that equal to 0 and solve, would tell me that x cannot equal a positive 1/2. And so when I look at these, neither of these is a domain restriction that's going to cause me any issues here because that x equals negative 22 is not one of the domain restrictions. And so again, that's the one thing I have to check. I have to make sure I get a valid x value, an x value that I'm allowed to use. Okay? If I look at the next couple, again, if I kind of think of that in terms of cross-multiplying, you think of that 0 as like over 1. When I do this, now I can cross-multiply. And what's really nice about cross-multiplying here is I do 0 times the x 2x minus 1, and I do the 4 times the instead of the x plus 4 times the 1. What happens here when I cross-multiply, when I do 0 times the 2x minus 1, it just gives me a 0. And when I do x plus 4 times the 1, it just gives me an x plus 4. Okay? So what I end up with is just x plus 4 equals 0. And now that's a really, really easy equation to solve. I just subtract this 4 from each side, and I find out that x equals a negative 4. And that's it. I can go back and check it against my domain restrictions. Again, the only domain restriction I would get here is that x cannot equal a 1/2. All right? If I played the same thing to the next one, again, if I think of this 0 as being like 0 over 1, well, now cross-multiply 0 times this denominator, and then this denominator times the 1. When I do 0 times the x squared plus x minus 3, well, that just gives me a 0. And when I do the x squared plus 6x minus 8 times the 1, it gives me an x squared plus 6 minus 8. And then from here, I just have to solve this thing. Again, if I rewrite it this way, it just feels right. It makes more sense when I rewrite it as x squared plus 6x minus 8 equals 0. Well, this is a quadratic, and I solve quadratics by factoring, completing the square of the quadratic formula. Well, we start with factoring. I build a bridge, two numbers that multiply to a negative 8 but add to a positive 6. Looks like it's going to give me... Well, it looks like there are no two numbers that that's really going to work for. So what I would have to do here is go to either the quadratic formula or completing the square. So I might complete the square with this one. It's absolutely 100% fine to use your quadratic formula here, but I'm going to add that 8 to each side, so I get x squared plus 6x with a little space equals 8. I complete the square, b divided by 2 and square it gives me a 9. Whatever I do to one side, I have to do to the other side. And so now this guy factors into an x plus 3 squared equals 17. And now from here I take the square root of each side. And just remember, when I do the square root of each side, I get x plus 3 over here. But when I do that, I have to do plus or minus that root. And then I subtract the 3 from each side. All right. And again, remember that when I do this, I can absolutely do my quadratic formula instead. That gives me x equals a negative 3 plus or minus the square root of 17. But keep in mind, when we have an a value that's 1 and a b value that's even, completing the square is really the way to go. And what's interesting here is I have to compare this to my my domain restrictions. But when you think about domain restrictions, think about setting this denominator equal to 0. Because this thing can't be factored, when we do this, if I build a bridge, negative 3, two numbers that multiply to negative 3 but add to a 1, it's not going to happen. I would have to solve this using either completing the square or my quadratic formula. And really, unless this is the same equation, completing the square of the quadratic formula is going to give me unique answers, so I don't even need to finish solving this one, because there's no way that those domain restrictions are going to match up with my solutions. All right, so my two solutions are valid. And the other interesting thing that you should notice here is when you look at what happens after I cross multiply, you should notice right away that this is just my numerator equal to 0. And that this one is just my numerator equal to 0. And so as you continue to look at problems like that, look for a shortcut that might exist when we're equal to 0. But again, when we look at these things, eliminate fractions by multiplying through by the common denominator. Unless we have a single fraction on each side, then we go to cross multiplying. Okay?